I feel like you usually think of physical exhaustion sort of like a car running out of gas.
Oh, absolutely. It feels incredibly mechanical, doesn't it?
Yeah, exactly. Like you hit the gym for a heavy workout and you just burn through your ATP, which is, adenosine triphosphate,
Hmm.
essentially the cellular currency of energy that fuels every muscle contraction.
Right.
And eventually those muscle fibers just run out of fuel, the engine sputters, and you literally, physically have to stop.
Well, it is entirely intuitive to view exhaustion that way. I mean, as a hard biological endpoint that just cannot be bargained with. The fuel tank hits empty, the pistons stop firing, and the workout is just over.
Right. But then you start looking at how the human brain actually processes the feeling of fatigue. And suddenly that internal fuel gauge isn't so reliable.
No, not at all.
Your perceived physical limit might actually just be a negotiation happening in your central nervous system.
Precisely. And one of the most powerful negotiators in that process, interestingly enough, might be sitting right in your headphones.
Which is wild.
Hmm.
And that's exactly why we are dedicating today's deep dive to an incredibly revealing 2024 article. It's titled, Music Timing Differentiates Fatigue Perception and Performance During Isometric Strength Exercises, a crossover randomized trial.
Such a great paper.
It really is. It was authored by Eric Tsz-Chun Poon, Wing-Lam Kwan, Ching Chow, and Derwin Chung, and it was published in the Journal of Sports Science and Medicine.
And I think it's important to note that this is an incredibly rigorous piece of academic literature. I mean, it fundamentally challenges how we use audio during strength training.
Definitely. And the objective of our deep dive today isn't just to ask whether music improves your workout. I mean, most of us who put on our favorite playlist before a heavy lift already suspect that a good beat helps.
Oh, for sure. We all felt that.
Yeah, so the mission here is to investigate exactly when music should be applied to maximize your physical endurance and, delay the onset of fatigue, specifically during static strength exercises.
Right, and contextualizing the study requires looking at the broader landscape of sports psychology. Because, well, a vast amount of existing literature proves that music provides major psychological and physiological benefits for dynamic aerobic exercises.
Like running or cycling.
Exactly. When you are running on a treadmill or cycling through a hilly route, music provides a rhythm and it distracts you from that lung-burning discomfort. But researchers notice this glaring gap regarding isometric exercises.
Okay, let's unpack this for a second. Because to understand why this study was designed the way it was, we really have to understand why that gap matters.
It's a huge distinction.
Right. I mean, is an isometric hold realistically that different from a run when it comes to hearing a beat? Because when you're running, your feet can physically sync to the rhythm.
Yeah, the music drives the physical pace of your stride.
Exactly. But in a plank, you're just staring at a spot on the floor, trembling. Does the brain process the audio differently because you aren't moving your body to match the tempo?
Well, that absence of movement is the very core of the issue with the previous literature, because the studies that showed mixed results on music timing almost exclusively focused on dynamic movement.
Ah, I see.
Yeah, they tested athletes doing like a 5-kilometer cycling time trial or a 6-minute all-out sprint, and in those scenarios, you have biomechanical feedback.
Right, you're moving through space.
Exactly. You are generating a breeze, your environment is changing, you are pacing your breath to your steps. Isometric exercises, though, they strip all of that away.
Because you are just holding a static muscle contraction without any joint movement whatsoever.
Right. So there is literally nowhere for the brain to hide.
Wow.
None at all. Prior to this, there was one older study involving hand grip strength, but gripping a small dynamometer with your forearm muscles doesn't really elicit the kind of whole-body distress and systemic fatigue we associate with a demanding workout.
No, definitely not. It's not the same as a full-body burn.
Exactly. But functional isometric tasks like plank holds and wall sits, those are deeply relevant to real-world athletes, and they induce a very specific kind of highly localized, aggressively escalating discomfort.
Oh, anyone who has done a wall sit knows exactly what you mean by escalating discomfort.
It is brutal. The physiological demands stay constant. I mean, you are just holding the position, but the subjective pain ramps up exponentially the longer you hold it.
Which makes static holds the ultimate testing ground for finding the absolute limits of psychological distraction.
Precisely.
Okay, so knowing that planks and wall sits are the perfect torture devices for this experiment, let's look at how the researchers actually set up the trial.
The methodology is really quite elegant.
Yeah, they brought in 12 recreationally active young adults, 5 males and 7 females. and they instructed these participants to perform plank holds and wall sits to volitional exhaustion.
Which is a very clinical way of saying they went until they broke.
Exactly. Volitional exhaustion essentially means holding the position until your body physically gives out, or until your form breaks so badly, like your hips sagging to the floor in a plank, that you have just failed the mechanical requirement of the exercise.
And a single test would not provide enough data, so the researchers employed a randomized crossover design.
Right, meaning every single one of those 12 participants went through all 3 testing conditions for both the plank and the wall sit.
Exactly. And to ensure the fatigue from one session didn't skew the results of the next, they separated these trials by a strict 48 to 72-hour washout period.
Yeah, that washout period is critical. I mean, if you completely fry your core muscles doing a maximum effort plank on Monday, you need those muscle fibers to fully repair before you test a different condition on Wednesday. Otherwise, the data is just entirely compromised.
Oh, 100%. It would ruin the whole baseline.
So the participants went through 3 distinct conditions. The first was MEE, standing for music entire exercise.
Right. The music played from the very first second they got into position until they collapsed.
And the second condition was MDF, music during fatigue. Here, the researchers held off on the music until the participant hit a 13 on the Borg rating of perceived exertion scale.
And the Borg RPE scale is fascinating in itself. It is a standard clinical tool used to measure subjective effort, and it runs from 6 to 20.
Which seems like a random numbering system at first glance.
It does, but it was originally designed to roughly correlate with heart rate. So an RPE of 6 corresponds to a resting heart rate of around 60 beats per minute.
Oh, that makes sense.
Yeah, and a 20 corresponds to a maximum effort of 200 beats per minute. So hitting a 13 on this scale indicates a feeling of being somewhat hard or a little tired.
Okay, so in this MDF condition, the participant is staring at the floor in absolute silence, feeling the burn slowly build up in their quads or their abs. And only when the effort becomes genuinely uncomfortable does the music finally kick in.
Exactly. They wait for the pain to start.
Right. And the third condition was Kwan, the control. Pure silence from start to finish.
Which sounds miserable.
Truly. And for the music conditions, the researchers wanted a genuinely motivating stimulus. They didn't just subject everyone to the same generic instrumental track.
No. They let participants choose their own preferred high-tempo music.
Yeah, with the strict criteria that it had to be over 120 beats per minute, and it was played at a volume exceeding 70 decibels. The average tempo chosen actually ended up around 151 beats per minute.
Which is an aggressive, highly motivating pace.
Yeah.
And delivered at a volume loud enough to ensure the audio is a prominent environmental stimulus that just cannot be easily ignored.
Okay, wait, I need to stop you there for a second. We are looking at a sample size of 12 people.
Yes, 12 participants.
I mean, can we really draw definitive scientific conclusions from a dozen college students? Usually, when you hear about major medical or psychological studies, you want to see hundreds, if not thousands of people in a trial to prove the results aren't just a fluke.
Yeah, that is the immediate reaction most people have when looking at sports science literature. But it really comes down to the statistical architecture of this study. This is a within-subject crossover design.
Okay, explain why that matters.
Well, when you have 2 separate groups, say 100 people listening to music and 100 people in silence, you have to worry about between-subject variables.
Like, what if the music group simply happened to include a few people with naturally stronger abdominal muscles?
Exactly, or people with higher baseline pain tolerances. But by having every single participant act as their own control, you completely eliminate the noise of individual genetics and fitness levels.
Oh, I see. So you're only comparing John's silent plank to John's music plank.
Precisely. And the researchers also ran a priori statistical modeling, a G-power analysis, before the study even began.
Ah, so they planned for the math ahead of time.
They did. Based on the data from previous literature regarding music and exercise, they anticipated a specific effect size, which is denoted as F0.4 in the paper. And when you run the mathematics for a repeated measures design looking for that exact degree of change, 12 individuals is mathematically determined to be a robust sample size.
Really?
Yeah. It provides the statistical power needed to detect rare, meaningful differences while minimizing the chance of false positives.
Wow. Okay. So it is about the precision of the comparison rather than the sheer volume of bodies in the room. That makes a lot of sense.
Exactly.
So, with that rigorous methodology laid out, let's look at the actual outcomes of this torture test. Who lasted longer and under what auditory conditions?
Well, the primary findings revealed a pretty stark contrast. For both the plank hold and the wall sit, the ME condition, having the music playing the entire time, resulted in significantly longer total time to exhaustion.
Okay, so playing music the whole time wins.
Yes. And furthermore, it significantly delayed their time to fatigue perception compared to the no music control.
Meaning they held the plank longer and the clock ticked much further before they even registered that they were working hard.
Correct. But the MDF condition, the group that waited for the fatigue to set in, that turned out to be a massive letdown.
Really?
Yeah. Waiting to hit play until the participant reached an exertion level of 13 had barely any impact. In the wall sit, it offered only a modest improvement in the time to exhaustion compared to total silence.
And what about the plank?
In the plank, it offered absolutely no significant improvement at all.
Wow.
And most surprisingly, introducing the music when they were already tired did not significantly delay their overall perception of fatigue in either exercise.
That is wild, because the intervention itself is fundamentally identical, right?
Right.
The brain is receiving the exact same audio track at the exact same high volume with the exact same fast-paced tempo.
Yes, the exact same stimulus.
Here's where it gets really interesting. If the exact same high-tempo 150 beat per minute song is playing, why does turning it on later suddenly strip it of its ergogenic power?
And by ergogenic, we mean that performance-enhancing, fatigue-delaying boost.
Right, because you'd logically assume that if you are trembling 3 minutes into a wall sit, staring at the wall, and suddenly your absolute favorite high-energy track drops, you get this massive surge of adrenaline that pushes you further.
You would think it should act as a second win.
Exactly. Yet the data clearly shows it just doesn't work that way.
No, it doesn't. And to understand the failure of that late-onset music, we have to transition from looking at a stopwatch to looking at the cognitive mechanisms of the brain.
Okay, tell me more about that.
Specifically, we need to look at the socio-cognitive model and the parallel processing model of pain. You see, the human brain operates with a strictly limited attentional capacity.
Like RAM in a computer.
Yeah, exactly. Think of your conscious attention as a bandwidth connection. You only have so much data you can process at any given millisecond. During intense exercise, your brain has to choose how to allocate that bandwidth.
Okay.
It can focus on disassociation, which involves processing external, environmental cues like a great song, an interesting conversation, or the scenery outside. Or it can focus on association.
And association would be processing internal bodily signals, right? Like the burning in your muscles, or the heavy rhythm of your breathing, or the trembling in your joints.
Precisely. So when the music is playing from the very start, during that ME condition, the audio occupies that attentional bandwidth before the physical pain even arrives at the server.
Ah, so it acts as a cognitive buffer.
Exactly. You are preemptively filling the brain's attentional space with an external, highly pleasant stimulus when the physical cost of the exercise is still extremely low.
Right, because the first 20 seconds of a plank are pretty easy.
Exactly. And as the physical hold becomes more demanding, the music is already established, dominating your cognitive processing. The pain signals basically have to fight for whatever leftover bandwidth remains.
That is fascinating.
But if you wait until a participant hits an RPE of 13, that tipping point where the effort becomes somewhat hard, their somatic awareness is already running at full capacity.
Meaning the brain's entire bandwidth is already dedicated to monitoring the physical distress.
Yes. The internal bodily sensations are screaming far too loudly for the delayed music to break through and force a disassociation.
Wow.
The researchers even highlight functional MRI data pointing to the left inferior frontal gyrus, which is a specific region in the brain responsible for processing interoceptive signals.
And interoception is basically your brain's ability to perceive the internal state of your body, right? Like knowing your heart is racing or your stomach is full.
Exactly. When music enters the auditory cortex first, it functionally modulates this brain region. It literally reduces your baseline exercise consciousness, intercepting those early physical distress signals before they fully register in your conscious mind as pain.
Okay, so is it essentially like trying to ignore a fire alarm?
How do you mean?
Let's say you put on a heavy pair of noise-canceling headphones and start blasting a playlist before the building's fire alarm even goes off. When the alarm finally triggers, you might not even notice the siren right away.
Right, because your auditory system is buffered.
Exactly. But if the alarm is already blaring in your ear, the strobe lights are flashing, and you are fully aware of the emergency, Putting the headphones on at that point doesn't magically make you forget the building is on fire.
That is perfectly said.
You might hear the music, but your brain is still completely focused on the crisis.
That analogy captures the neurological reality perfectly. If the fire alarm, which in this case is the accumulation of metabolic waste and the mechanical stress in your muscle tissue, if that is already the dominant sensory input, throwing a heavy metal song over it does not put out the fire.
And it does not erase the alarm.
No, your cognitive resources are entirely consumed by managing the perceived crisis in your quadriceps. And this is why the delayed music failed to provide that second wind. The critical attentional threshold had already been crossed.
So the brain simply refused to allocate resources away from the physical threat to process the music.
Exactly.
It is wild to think about how much of our physical experience and our perception of our own limits is dictated by cognitive routing. But, this raises another major question regarding the physiology.
What's that?
Well, if the brain's perception of the pain is changing depending on when the music starts, is the body's actual physical response changing as well? Like, if I feel significantly less tired because I started my playlist early, is my body actually producing less fatigue waste?
And that is a great question. The researchers anticipated that exact query. Alongside all the subjective psychological surveys, they meticulously measured heart rate and blood lactate levels.
Oh, okay. And lactate is a metabolic byproduct produced when your body breaks down carbohydrates for energy during intense exercise, right? It's largely responsible for that intense localized burning sensation.
Exactly. They took these measurements immediately before and immediately after every single task.
And the physiological data they pulled is incredibly revealing because the different music conditions had absolutely zero significant effect on the changes in heart rate or blood lactate levels in any of the trials.
None at all.
It did not matter whether they listened to music the whole time halfway through or suffered in total silence. Their physiological markers of stress, the actual biological toll the exercise took on their bodies, were statistically identical across the board.
Which presents a stark contrast to some studies done on dynamic exercise, actually.
Oh, really? How so?
Well, for instance, in a running test, introducing a strong musical beat might actually help lower a runner's blood lactate, because the rhythm can help the athlete find a more biomechanically efficient stride or regularize their breathing pattern.
Oh, which physically alters how the body consumes oxygen and clears metabolic waste.
Exactly. But static holds operate under completely different physical rules.
Because there is no biomechanical rhythm to improve. You're literally just staying still.
Precisely the issue. You are not moving. You cannot find a groove to make a wall sit more efficient. The physiological demands of forcing your leg muscles to support your body weight against gravity remain entirely constant regardless of your audio environment.
That makes total sense.
Yeah, your muscle fibers are firing, consuming ATP, and pooling lactate at the exact same rate whether you are enveloped in a 150 beat per minute track or in dead silence.
And I guess the local blood flow restriction caused by the constant muscle contraction just traps the lactate there either way.
Yes, exactly.
So what does this all actually mean for the person doing the exercise? If our heart rate and our blood lactate accumulation are identical across all three conditions, are we literally just tricking our brains into holding a plank longer?
Basically, yes.
Like, we aren't actually becoming more physically capable or more fit with the music. We're just becoming better at lying to ourselves about how much pain we are in.
In a neurocognitive sense, absolutely. We are actively hacking our own perception. The performance-enhancing effect of music during a brutal isometric hold has nothing to do with giving you more physical fuel.
Right.
Or changing your cellular capacity to clear out lactic acid. It is entirely about extending the timeline of your subjective tolerance. It delays the perception of fatigue rather than increasing your biological resistance to that fatigue.
That is just mind-blowing.
The muscle tissues are sending the exact same distress signals up the spinal cord, but the music effectively turns down the volume of those signals in your cerebral cortex, and that allows you to endure an identical physiological state for a much longer duration.
It is an incredible mechanism. I mean, the body is sounding the alarm, the heart is pounding, the lactate is burning the tissue. But the brain is so happily occupied by processing the rhythm and melody of a fast-paced track, it just flags the pain signals as red and ignores them for an extra 30 or 40 seconds.
It is a profound, quantifiable demonstration of mind over muscle. And the data from this crossover trial definitively proves that the timing of that cognitive distraction is the single most critical variable.
Because you cannot wait until the neurological inbox is already overflowing with high-priority distress signals to try and apply a spam filter.
That is exactly it.
So what does this mean for you the next time you hit the gym?
The practical application of this research is actually incredibly straightforward.
It really is. If you want to optimize your strength training, especially when you are facing down those grueling static holds or functional isometric exercises, do not save your favorite playlist for the end of your workout as a motivational crutch.
Which is what so many people do.
Right. So many of us have that instinct. We hold off, we endure the silence, and we wait until that final hardest set to drop the bass and try to hype ourselves up for a final push. But this data explicitly tells us that strategy is deeply flawed.
Deeply flawed.
You have to start the music early, play it constantly, and let it occupy your attentional bandwidth before the physical fatigue can set in. You have to build that cognitive buffer while your muscles still feel fresh.
And pulling back from the gym for a moment, the underlying mechanics of this study leave us with a truly fascinating concept to mull over.
Oh.
Yeah. If a simple shift in auditory timing can significantly extend our absolute physical limits without changing our physiological state by even a single heartbeat, we have to wonder, in what other areas of life is our exhaustion entirely dictated by where we allow our attention to sit?
Huh?
Right. How many of our perceived limits, whether mental or physical, are simply a matter of sensory routing?
That is a brilliant point. I mean, how much of our daily burnout, whether it is tackling a massive project at work, managing a stressful routine, or just getting through a difficult afternoon, is just us staring at the metaphorical floor in silence?
Letting the internal distress and anxiety dominate the spotlight before we even try to find a distraction.
Exactly. It's definitely a powerful framework to consider. The next time you feel like you have hit your absolute limit in any endeavor, the limit might not be mechanical, it might just be attentional.
Absolutely.
Well, we strongly encourage you to seek out and read the full article by Poon and colleagues in the Journal of Sports Science and Medicine. The methodology, the statistical breakdowns, and the neurophysiological models detailed in the paper offer such a deeper, incredibly rewarding understanding of how our brains process physical distress.
It is a phenomenal piece of literature.
It really is. And to make sure you don't miss out on more scientifically rigorous content, diving into the mechanics of the human body and mind, please remember to follow the channel and turn on notifications.
Because there is always more literature to unpack and more mental models to challenge.
So true. So the next time you are gearing up for a heavy workout, remember that feeling of the physical gas tank being empty. It might just be your central nervous system trying to trick you into stopping early. Turn the music on before you even start the engine, and you might just find out you had a massive reserve tank all along. Thanks for joining us on this deep dive.